Welcome. Today we will review UEI's Eagle-X Combustion Analyzer, which uses the latest sensor technology known as electro-optical sensor, or EOS. And if you perform combustion analysis, you're going to want to hear this. Our sensor technology provides several key benefits to make your job easier. First, a brief history. The first combustion analysis was done by measuring carbon dioxide, CO2, using a CO2 indicator, or dumbbell, and measuring the amount of smoke produced indicating carbon monoxide, or CO. By observing the CO and CO2 levels, a technician could accurately adjust an appliance's fuel ratio, determining the ratio was too rich by measuring CO, or in this case, smoke. Appliance manufacturers would specify, and still do, target levels for CO and CO2. Then, flue gas analyzers came along, and there was no way electronically to measure CO2. So an oxygen sensor was used to measure oxygen, and, this is very important, calculate CO2 based on the fuel selected. So you could still observe your target levels of CO and CO2. This was more convenient and a faster way of work, which was great, but problematic because the oxygen sensor was constantly exposed to oxygen and would wear out. And remember what I said about calculations? If the fuel was not set correctly, the calculations would be incorrect. Why not measure CO2 directly? At this point, the technology wasn't available. The thing to note here is because of the technology, oxygen readings were now being looked at to verify proper combustion and used to calculate efficiency, using a sensor that was constantly being worn by exposure. Our understanding of combustion analysis changed based on the lack of technology. So now people believe if you do not directly measure oxygen, you are not seeing the full picture, when the reality is our understanding was based on the technology we had, and not the picture at all. The technology has changed, and so should our thinking. While other manufacturers are trying to find ways to get you sensor replacements faster, we decided to build an analyzer that needs fewer replacements. To understand the difference between the two technologies, let's look at how these two sensors differ. Let's start with the traditional electrochemical sensors. They have cells with electrodes and a specific chemical that react with the gas as it passes through, generating a small electrical current. The current is relevant to the concentration of gas, providing the analyzer a reading. Over time, the electrodes erode and the chemical dilutes, resulting in long-term drift and eventual failure. And, in the case of the oxygen sensor, which is constantly exposed, wears out like a battery, even while it's sitting on distributor's shelf waiting to be sold. Now let's talk about EOS sensor technology. We started first by removing the electrochemical O2 sensor. We replaced it with an electro-optical CO2 sensor. Sample gas passes through a chamber where an infrared sensor scans the gas, detecting the amount of CO2 in percentage. The advantage here is that the gas never comes in contact with the sensor to wear it out. That's a direct measurement, not a calculation, of CO2 from a sensor with no calibration deterioration and a 10-year life expectancy. Our EOS technology is a new way of thinking, and it's exclusive to UEI. Of course, our competition is going to try and talk you out of using this because it's something they can't offer you.